Okay, I want to welcome everybody to our webinar, first part of a webinar series we're doing. Part one is going to be on safe, smart, seamless, navigating HMI hurdles in lab equipment. And the theme, kind of the sub-theme is, building intuitive and effective user interfaces for clinical precision. Let's jump right in. Oh, before we jump right in, let's get some housekeeping notes here. I just want to mention to our audience that there are two. I'm not sure. We're using a thing called Livestorm, so I'm not sure if you're familiar. Just down at the bottom, there's a chat and the questions. We are not monitoring the chat. We're going to be monitoring the questions area. So if you'd like to submit a question while we're going through our little presentation, please do, and we'll have a question and answer at the end. All right, so without further ado, let's jump in. I'll introduce myself. My name is Roger Mazzella. I'm the Global Medical Industry Leader for Cute Group. Been with the company for about almost 9 years and really leading the charge here in the medical industry. And where clinical lab equipment, we consider a subvertical of the medical industry. And joining me today, not as formal as he is in his picture, but joining me today is my colleague, Sam Davies, who is a Senior Solutions Engineer and been with us for a while. Sam, if you'd like to introduce yourself.
Yep. Thanks, Roger. As you said, I'm a solutions engineer. Been with Qt for a bit over 3 years now. Prior to joining Qt, I was working at a medical device company. So I have a little bit of experience in this industry and hoping to bring that experience to the webinar and help guide the discussion and navigate the different challenges that are present in this industry.
Yeah, and so just wanted to make casual some of the company and what's great about our team is, I think we have a great product that's been really successful in the medical industry for quite some time. Our focus is now, we've been focused on medical devices a lot. A lot of the content you see put out there is on medical devices, but we look and say, we do have clinical lab equipment kind of manufacturers and developers working with us as well. And so, as we move into from 2025 into 2026, we're starting to focus on those use cases where the risks and the value and some of the pain points are a little different. And Sam, the company and what's great is our team, many members of our team have worked in medtech before for medtech manufacturers, whether it be medical devices, clinical lab equipment. And Sam, just to give a little more of your background and why I chose you to help me out with this webinar is you actually work for a point of care kind of diagnostics company. So kind of point of care lab diagnostics.
That's
correct?
right. I was working on a team that made blood gas analyzers. So very
Fantastic.
relevant specifically to the clinical lab space.
Yeah, and that's a little preview of something we're going to show at the end of the webinar. But let's jump into the content. So we have a really great agenda. We don't have a lot of slides, but I think we have a few slides to really generate a discussion between Sam and I. So we're going to go over some things here. Again, please feel free to put your questions in the question section. But agenda is we're going to start painting kind of the picture here of why HMI matters in clinical labs. We know that HMI is becoming more important with usability and such. So we're going to define that a little bit. And then we have kind of a little thing to ground us here, the 3 S's, and we'll go over that when we touch that. And then we're going to go through industry essentials, where just really the challenges that we see facing this industry and some of the remedies that we know from our experience that we could suggest. And then we'll tie everything up and kind of a wrap up in Q&A. So first and foremost, why HMI matters in clinical labs, and sometimes this may be evident, but sometimes it may be kind of like, well, it's a clinical setting. I know where HMIs, let's say, in our everyday life, right? When we're using consumer products or even in our automobile, right? These UIs are becoming more immersive, more engaging, more entertaining, more pleasant. And I made this mistake early on in my career where I looked at, when we were developing kind of products in previous positions, I looked at things that are very clinical and it's a clinical setting. Things are very, very clean and very sharp. And, that's not really, we got to realize there are people using this, right, Sam? So, that balance of, yes, having things very, being able to be very intuitive and readable and stuff, yes, very important and very organized. But at the same time, it's people using it, and the more enjoyable, dare I say, or the more immersive or more intuitive the experience is, the more it's going to be adopted, right? And Sam, from your experience, I think when you were developing these type of tools, and even stuff that you're doing for Qt now, we keep that in mind, even in these regulated kind of clinical settings.
That's right. And the key thing is really that the technicians have a preset workflow that they know that these are the steps that they have to take, and so now it's just ensuring that the UI doesn't get in the way of that workflow and
Mm.
actually facilitates that workflow.
Yeah, and how much do you facilitate that workflow without getting too creative, maybe, or too outside the box a little bit? But I see, different customers that we work with getting very creative and almost making things looking more kind of consumer grade from a UI perspective, right?
Yeah, it's no longer that the UI is simply kind of like a means to an end. Maybe what I had just said is a little bit on that side of things, right? It's like, oh, we have a workflow, let's make the UI just make this possible. But
Make it work, right,
um,
right.
but it has to be, like I said, it can't get in the way. It has to be guided. It has to be intuitive. It has to help them through the workflow and be simple.
Right, right. And so, we identified some risks and the impact of those risks. So, some of those risks, just real quick, are, user error, delayed results, wrong treatment, right? When we look at like kind of lab diagnostics and lab tools, it's not about the patient getting injured by the device, right? The device is not connected to the patient. In your instance, a blood gas analyzer, you're taking the blood from the person and then putting it in that device, and that device running is not going to hurt me, but could be, if it's used incorrectly, could be the wrong type of diagnosis, the wrong type of treatment suggested. But what I like about this too is the delayed results. It's sometimes when you're in that lab setting, and maybe in the hospital where you need lab results quickly, time is precious, especially in a high pressure situation, right? So where I like that we highlighted the wrong treatment, the delayed results is really also something that has to be considered from user
Yeah,
error.
and so the HMI has to mitigate the risk of the user error, because if you need a result quickly, you can't have the user accidentally click a wrong button and have to restart the entire workflow to get that
Yeah,
correct result.
yeah, and then
You
you go
need to
back in the
be able to
workflow.
remedy that quickly.
Absolutely. And then, cognitive overload, there's so much data. I mean, look at all the data that's being created from all these devices, right? You think of, and with AI coming into the picture, data is even more and more. So, you want to show everybody everything, but at the same point, we have to be cognizant of the cognitive overload, right? And that to just, burn people out or make it hard to use and so forth. And then obviously, we don't want downtime. We want the thing to continue to be operating. And what we've seen is, and some of the studies that we've looked at, there could be as much as $10,000 per hour and lost testing capacity from downtime. So along with the user error, there's that cognitive overload. We don't want to overwhelm people. We certainly don't want the device to be down.
Yeah,
We want
and
to be
Roger,
up
I
as
think that
possible.
that's one thing that's actually overlooked quite a bit is the whole burnout. It's
Yeah,
real, and it'll affect your brand if you have people in the field that say, "Man, I really don't like using this machine. It makes my job harder." You want the opposite of that,
right.
and so you want people to enjoy, or at least not feel like the machine is getting in the way of them doing their work.
Right, right. And so, we saw a statistic here, 85% of lab errors trace back to poor interface design. So the HMI is important. And then here, we're kind of trying to contextualize things. Where does everything converge with the UI, right? And we came up with kind of like, the UI has to be safe, right? Zero ambiguity, especially in critical actions, right? So safe and effective still applies to laboratory equipment as much as it applies to medical devices. And then smart, we want those workflows to be adaptive. And we're going to get into that in a little bit because there's, in the first, I think the next slide, we're talking about different users and different workflows and, how, to your point, Sam, how do we kind of continue to guide people with not getting in the way of that, right? Um, and then seamless, frictionless from login to label print. You just want a really seamless workflow, a seamless experience so that you get to that lab result, so you can get to that diagnosis and treatment quickly. Sam, anything else to comment on those three?
Yeah, just on the safety piece, right? Because that's, as you said, it's not, these aren't patient critical devices, right? These are analyzers, but there is still always the safety aspect, that's kind of inherent in multiple features of these machines. For instance, you have to have the QC in there, and you have to have calibration runs, and that really does tie into, okay, is this thing safe? I shouldn't be able to run a sample if QC needs to be run, if the machine's not calibrated, and those are the safety checks that are relevant in this space.
Exactly. So we have to keep our eye on the prize, so to speak, even when we're trying to push the envelope a little bit in the kind of creativeness we can have in creating those great user experiences and great HMI. And I love how we tied things into this goal here. This is very simple. It makes so much sense to me. The goal here is, one, think of that new lab tech coming in kind of green, maybe has experience, but maybe not experience with a certain equipment. And that person is overwhelmed a little bit because they're starting a new job. How do we get them onboarded quickly so that HMI has to be intuitive enough for that new lab tech to jump in and just hit the ground running, but then effective enough for a CLAI audit, let's say, right? So it's that thing that I always say, what's the value of something working as intended, being effective, if it's not used as intended? Any other comments on the goal before we start jumping into those industry challenges, Sam?
No, I think we're good to
Okay.
go.
Awesome. Great. So thanks for framing that. So we're now going to get into some of what we call the industry essentials, where there are challenges, and we're going to talk about why things are difficult, and start looking at solutions to move forward and recommend that for you. So Sam, the first one that we kind of took, and this is not exclusive to clinical lab equipment. This is, all medical, all med tech, right? We are seeing so many different user archetypes being able to use these type of devices. Now, looking at the medical devices, there's a lot more of this medical technology coming to the home, right? Lab equipment, I don't think we would see in the home necessarily. So it's not, I say this a lot when I talk, it may not be Dr. Judy or Nurse Judy treating you. It might be Aunt Judy treating you, but this is not kind of what we see lab equipment, even some of the point of care lab diagnostics where you're actually doing lab analysis. However, there are these kind of diversity of users. It could be everything from the actual lab tech to the manager, the person that's kind of overseeing the lab techs, to the technicians that's going to work on the equipment. So, there are all these different loads with different access levels and maybe even different workloads. And, adding that new role that we talked about previous to kind of jumping on live here, it is, might refactoring the application, and refactoring the application takes time, and then you have delays. What from your experience, Sam, how are we doing with this, and where do we track with this?
Yeah. So this is obviously something that needs to be baked in at the time of architecting the software. And you need to choose the right approach to this. Otherwise, you'll face some of these difficulties. You need to have a system that allows you to configure these things without having to refactor large portions of the application. So you need to have an intelligent design on how am I going to handle users and roles and user sessions, and then how am I going to restrict access to certain
Yeah,
things, but
permissions
also
and
show
stuff.
the
Sure.
appropriate things based
Right.
on the user. So really, the ideal here is that you have a framework that facilitates the creation of these user roles, but also dynamically changes the UI components based on the user that's currently logged in. So that
Right.
means that you're not having to design a screen for each one of the user
Mm.
roles. You have a user role, and the screen intelligently adapts to who's using the machine.
Yeah, that switch, depending on who walks up to the machine, could be different. And we see that reusable UI components, and creation of these roles make it easier to switch nimbly between these type of users. Sam, any kind of estimate though on what how much time does refactoring take? Could it take minutes, seconds? What's your experience with that?
Yeah, if this wasn't thought of at the beginning, and if this wasn't done properly, then a refactor uh, could be a really big endeavor. If this thing wasn't architected properly from the get go, then you're we're talking about refactoring each screen potentially.
Oh,
So
so it
it's
could be minutes, right? It could be minutes,
if
and that's a
if you've
long
done
time.
things properly,
Yeah.
creating a new user and a new role and restricted access is going to take much less time than if you've bolted
Yeah.
this on after the fact, right?
Okay. Yep. So
And
planning ahead of time, sure.
this ties back into actually this multi-role requirement does tie back into something that you had mentioned about the ability to trace which user took what action on the machine. So like an audit log of
Mm,
this is the user that was logged in and these are the actions that they took. So
right.
that's another reason why this is such an important piece is we need to have a trail of who was logged in and what actions did they take.
Yeah, and I think we're going to get into traceability a little bit later. So great point. Okay, let's continue to move on. So another challenge is we talked about so much data, and a lot of that data is in real time, right? And depending on where the lab equipment, the context in which the lab equipment is it used in a trauma situation where you need results quickly? Can it be a little bit more time, right? But there's a lot of data being generated, even more data being generated as we continue to move forward. And all this data, everyone thinks their data is useful, right? So you want to see everything. But this is where we start getting into that overwhelming, you can overwhelm folks with data. So lab analyzers, as we say, the challenge, generate large complex data sets, right? So how do we balance that real-time performance with optimal data visualization? I don't think there's a one kind of answer that answers that, right, Sam? It's more depending on the use case, depending on the data, also depending on the actual type of equipment. And so the ideal solution may not be just a one size fits all, correct?
That's right. I mean, behind the scenes, these machines are collecting an enormous amount of data when they're running these samples, and the reality is you need to decide what is relevant for the technician to see. You don't need to, in most cases, show them the reaction curve coming in real time. They need the end result. What was the
Right.
final reaction curve, and what was the determination based on what the machine, the scanning that the machine did. So they don't need, oh, I have 50,000 samples every second. I need to see those in real time. I need to see this, and this, and I need an easy way to just to put that on the screen that's easily readable.
Yeah, and it has to be deterministic and latency free, as we're saying in the solution. Correct. It can't delay. The more data you show, the more longer it's going to potentially take. But then it has to be deterministic. You have to have it so that people can make decisions. Correct. So, as the result, consistent frame delivery, predictable performance, even under high data throughput. So even in this high pressure kind of lots of data situation, you have to be able to architect your screens such that you have that important information. Maybe some of the ancillary information could be buried, in a sub screen somewhere. But these decisions have to be made, as you had mentioned in the previous slide, previous to actually getting into your design. This is the prep work that we see people doing, that we work with.
Yeah, and I think that the deterministic part, this comes in to when you're talking about using compiled languages versus interpreted languages, and you're talking about performance and things like multi-threading, and is
Mm,
the screen going to freeze up on me while something's running? These are things that are unacceptable for the device to do. So you need to make sure that you're choosing a solution that allows you to have the screen automatically update once data becomes available, and it should never hang on the user.
yeah, absolutely. Yeah, performance is key as well. And the more data you have, the more performance could be at risk, right? So, Excellent. Okay, so moving on. Future proofing. Gosh, have I run up against this over my career the past how many years? And people think of kind of like our solution, like a multi-platform solution where it's cross-platform. They think about multi-platform, they say cross-platform, but when you say multi-platform, it's also future-proofing, that the platform you're on today may not be the platform you're on tomorrow, right? As things evolve and innovation evolves, and maybe they're a better choice in the future that are not here now. So that situational flexibility with that future-proofing in mind becomes a real essential. And the adaptability, as we're saying in this challenge, comes with the combination of the operational variability need plus the long-term evolution of your device. So Sam, do we have to have crystal balls and know how things are going to be in the future? You know what I mean? Because that
Yeah.
long-term evolution almost seems like, how predictable do you have to be in order to bake that into the design that you have?
Yeah, the good thing is no, we don't need a crystal ball. All we need to know is that we don't have a crystal ball and
Mm,
make anticipations for, hey, we should design our application to have to be modular from the get-go. So that
right,
means that if we need to add a new feature, if the device needs to have a new sensor connected to it, that the UI can automatically display the information from the new sensor without you having to push a new version of the app. So it's
right.
being modular from the get-go, saying, hey, I need to drop in this new feature, and the UI can dynamically display that new data that's coming in.
Right. And I think you just really articulated very well that first bullet, that same software across different hardware configs, different environments, right? And then, making it flexible enough where, yeah, we don't have that crystal ball. We don't know what's coming, especially in the advent of AI. I mean, how is AI? I mean, let's not even touch how AI could be put into some of these, right? But with
Yeah.
that and what's coming and these different models coming and such, it's not predictive that you have to predict that now, but you have to make it flexible enough where you can implement that, almost plug that in, so to speak, as these new innovations, as you evolve your product in the future.
Yeah, exactly. And so that kind of brings in what is the ideal solution to becoming future proof, and that's becoming as agnostic as you can to the
Mm,
underlying platform. So it doesn't matter if, hey, we built this machine on this vendor's hardware and now they're no longer supplying it. What should we do? That's a big challenge
sure.
if you haven't planned for platform agnosticism in the get-go, right?
Yeah.
So being able to say, hey, I don't, the framework that I'm using doesn't matter about what it's running on top of. That
Right.
gives you a lot of freedom to say, hey, if this is unavailable, then we'll just switch to this other platform, and guess what, I'll still be able to run my same software there. So it gives
R-
you freedom in how you actually want to um, build the machine and what hardware is going into there without you having to recreate software specific to that platform.
Yeah, and what we put in the result here, I think, really captures that, right? We want to support plug-in architectures, right? That result in cost reduction for the life cycle and also have competitive advantage. But that plug-in, I think what you're describing is that plug-in scenario where you have a solution that's flexible enough to be able to accept that, right?
Yeah, and in this space, it's mostly we're talking about embedded Linux
Right,
and
right.
some real-time systems as well. But having a platform that plays very well with the embedded Linux space is a huge win for this.
And we're seeing that. That's a great point. I appreciate you making that because we're seeing embedded Linux across all med tech, right? And the interesting thing is that the RTOS is here. We're not seeing as much in the lab equipment, right? But are you seeing some RTOS architecture here with these? Just curious, because we're seeing it a lot in the medical device space with the functional safety with hospitals.
Yeah, we we do see RTOS systems. It's on I'd say maybe a little bit unusual for the microcontroller running the RTOS to have a screen itself. It's
Mm,
typically the machine will have one platform, maybe a microprocessor running an embedded Linux that's running the UI, and it will send commands to the real-time
Right. Okay. Right.
microcontroller.
So it
So
has
it's
nothing
a
to do with the HMI,
microcontroller.
but it's still inherent in the system.
Yeah, microcontroller and RTOS is doing the hard number crunch, the sample collecting,
Right.
and then it's reporting the data back.
Got it.
There are
And
some
just to,
devices, of course, that have their UIs being run by the microcontroller itself. It's just less common.
no, and that's a great point because I myself am not a software developer. I know enough to be dangerous sometimes, and but I think it's great because I wasn't even thinking of that. So maybe some of the folks in our audience that maybe are not as deep in the technical weeds as you are, that was a great point, and I appreciate you making that. Okay, so let's move on to the next one. And so here, we're seeing connectivity, right? And boy, 20 so years ago when I was working, it was almost like, well, even before the pandemic, all the way up to the pandemic, it was like, don't connect your device unless it has to be connected, right? I remember working with customers in the past and them saying, no, we're not connecting this. We don't even want to touch that. But now, post pandemic, everything's connected, right? Because what the pandemic showed us is we need remote care, and that was always kind of in the background there, but not, it was almost like a nice to have. But after the pandemic, now it's a must have, right? We must have these, and we, I think what we saw was, especially in elder care, it's interesting going and visiting different geographies that I've visited, like in APAC, where the older, they have a increasingly large elder community, and they don't want these people being in hospitals. They don't want these people being in. So the more we can connect these devices and get them outside the hospital, and I know we're talking more medical device, but I think this is trickling over to obviously lab equipment too, because everything's getting put into an EHR, everything's been put into a lab information system. So, the challenge is that, these standards like DICOM, like FHIR, HL7, even SDC are being rapidly adopted for interoperability with lab information systems in EHR. And I know with the lab information system, it's not as much DICOM, which is imaging, it's more of that data. And so, these are complex standards and with network protocols. They're not simple kind of REST APIs. And FHIR is actually rapidly evolving because we understand is the HL7 original standard was kind of difficult to work in. So now FHIR is actually being promoted, but then there's the SDC kind of regulations. It's really a complex type of environment. But at the end of the day, when our customers are building these lab equipments and the people that the technicians are using them, that data has to get put into an LIS or an EHR. And how is it done? It's got to be converted into these standard formats for communication that these electronic health record systems accept. And so, Sam, I know I've been talking a little bit about this because this is kind of the slide I put together, knowing that I have a little more experience with this. I'm not sure if you have anything to weigh on here, but I know that we at CUTE are looking at this and saying, look, we across med tech, so lab equipment, medical devices, and health IT systems, we're working with a lot of the top companies. Our customer base is pretty extensive in medical. And so we know that our customers are using kind of alternative ways and alternative methods to get what's rendered on the screen into these different types of formats. But they're using stuff outside of our technology. So I just wanted to kind of shift a little bit because I wanted to give a little peek into our roadmap. Is I am considering working with our product teams to put these type of things in the software stack of CUTE. So you have a native CUTE way to convert into and out of DICOM, into and out of FHIR. And so we're making those decisions now. And I could tell you some of the customers that we've already spoken with, very excited about this because there's no native way to do this. I would love for our audience, if you guys think that this would be, we'd love some feedback. And so I'm just doing a little bit thing here for the help of as we're engaging a pretty big audience today. For those of you who are familiar with our technology, we're looking to see if this would be of value. We'd love that commentary. But all in all, the ideal solution is a built-in framework to support these things. And that's where we're trying to see if we drive our product, if it would be contextual for us to do that. And obviously building this better architecture saves costs, saves time, saves the regulatory burden. There's not these workarounds or glue code or bridges that have to be done to kind of connect these things or do these conversions. So we're seeing value in that. We're hearing from our customers for that. We'd love to hear from our audience. But Sam, again, I know this was an area that I'm kind of passionate about and really digging into. Did you have any other comments or observations for
I
this?
think you hit the nail on the head, Roger. As you said, these things are already, easy to integrate with our technologies. These third-party libraries for, viewing, manipulating, saving DICOM images, and then the FHIR, at its core uses, some standard data formats.
Yep.
It uses XML and JSON. So off the bat, those are things that, we would have a clear path for having a in-house, native solution for those types of things too. So it's very, really exciting road ahead for
Yeah, and
what
I
you
think
just said.
we're going out of a horizontal product to try to facilitate more medical specific things, whether it be lab equipment or medical devices or whatnot. So, yeah, no, good, thanks. And this is something that we're seeing, and I wanted to include this because if you're not familiar with this environment, it could get very, very tricky sometimes. So moving right along, quality assurance, obviously, in device development validation. I mean, this is a no-brainer, right? Rigorous quality assurance is required through the entire development cycle, not just final product testing, building that testing early and often. And I know, from our experience, Sam, when we're working with customers, Qt has acquired some testing companies, so we actually have testing tools now to facilitate this. And we're advising people, look, don't save those tools for the end, right? Start using those great tools and start doing your validation early and often, even if it's rough, even if it's just kind of down and dirty a little bit. Starting that validation process, even in the beginning and throughout is really the key. Your comments on that, Sam? Sorry.
Yeah. Testing more frequently, and earlier. That's kind of the key to avoiding delays, right? The sooner that you find something, the easier it is to fix that thing, and
Right.
that's really true, because if you find something much later, who knows what else has been built on top of that problematic section, right?
Right.
Um,
Right.
and you know, nobody enjoys it. It's not a fun, testing isn't seen as this super fun thing to do. It's most people see it as a necessary evil, but if you do it properly, you're going to save yourself a lot of headaches, a lot of time, and you're going to get to market faster.
Yeah, and what I like what we've called out and why it's difficult, I like that first bullet. Traditional manual testing can't keep pace with the iterative development cycles. So where manual testing might be good in the beginning as you're prototyping and stuff, switching to an automated testing, and there's so many tools out there to do that. We have one as well. Really is the way to go to make it more efficient, not efficient, fast, but also consistent, right? Running those same test scripts, because there's human error. If you're trying to run the same test scripts manually, maybe you don't have the same patterns. So I think calling that out was really key in the difficulty that we're showcasing here.
Yeah,
Um,
that's a great point. Making use of the automated testing tools will, like I said, that's what allows you to do more tests. You're testing more frequently. You can test on every code push instead of saying, okay, on Friday, my coworker, that's when he does all of his tests, so I'm gonna have to wait to
right.
see what he finds. And as you said, it eliminates the human error as well. You
Yeah.
have 100% guaranteed that the test is being run perfectly, and there are no buttons that are missed, accidentally clicked, values that are entered incorrectly. You
Yeah.
have 100% certainty that the test was run at this time. These are the exact steps that happened, and you know that the result is good because there is no ambiguity. there's no human
Right.
error.
Yeah, I think ambiguity is key. That's a real pain point. And so, obviously gaps in that test coverage become regulatory risks, and discovering bugs late in the game is much more expensive to fix than finding them earlier. So, we're looking at the ideal solution, that integrating testing framework enables continuous validation through the development cycle, and that this results in a reduced validation phase. I mean, same time from months to weeks. That's huge. That's pretty huge. So anyway, anything else to kind of
Yeah,
sum up this slide that you'd like to
yeah,
say? Sam?
yeah. The ideal solution. Just want to touch on that
Sure,
because this
sure.
whole idea of it being integrated is really important. It needs to be easy to do. You don't want to say you have to go over here to do that, and then
Mm,
you have to come over here to show me what happened. You want all of these tools to be working in harmony to make everything cohesive and faster. So the
right.
developer shouldn't even have to know that test is going to run. He should just do his work, and the test is going to be run automatically.
Mm,
That's what these integrated systems provide, is like letting people focus on what's important in their role, and ensuring automatically that the work that they've done is good work.
yeah, and I know some of these automated testing tools are coming in with AI too, which even helps facilitate that automated process faster. I know we're putting into our tools, shameless plug, but I know other tools have that as well. So, the advancement of innovation is not just applying to development; it's applying to testing as well.
Yeah, and before we move on, of course,
Sure.
there's multiple parts of testing, right? There's static code analysis, there's unit testing, then there's full systems test, there's automated UI tests, and being able to have a solution that provides all of the types of testing to you is also of great value, and that's something that we do.
Yeah, fantastic. All right, so we've got a couple more slides, then we're going to wrap up. So obviously, design control traceability. We mentioned this. You mentioned this in the beginning. I knew we were going to come back to this slide, Sam. So design controls, traceability for regulatory compliance. Everything needs to be completely traceable, from user needs to design inputs to the verification and validation. And obviously, the FDA 21 CFR 820 calls that out. So every button, workflow, error message needs to be documented, justified, rationalized, right? And sometimes traditional development with those disconnect tools create those traceability gaps. I know that I in the beginning of my career, I was a QA engineer working on patient monitors, and boy, the paperwork we had to do to have that traceability way back then, and now I know it's even more. Comments on traceability, Sam?
Yeah, this is a slide that actually brings up a different area that we've kind of skipped over, the whole design
Yeah,
stage,
yeah,
and this
yeah.
is where this comes in. And so this ties the whole process together. It comes from an idea and an understanding of what the user requirements are, and then saying, okay, these are the user requirements, these are the essentials, this is what the machine has to do, this is what the
Mm,
user has to be able to do with this machine. How
mhm.
do we then take those requirements and design a user interface that meets those requirements, while still remaining simple to use, right?
Yeah, yeah.
And with QML specifically, it's a declarative language, and the design specification is also the QML file itself, right? It's the input, it's the specification and the implementation all in one file. So
Mm.
that's a huge benefit right there, is being able to have a declarative language act as both.
Yeah, and we're adding, again, we're finding this very important, and we're seeing challenges in that traceability and the accuracy of the information, especially as it applies to usability, right? I've been in kind of these pre-market and post-market surveillance situations where somebody is either observing or being interviewed about their use of the device, whether it's lab equipment or medical device or whatnot, and they're not, maybe they're not looking at every single button push like an engineer would, right? They're a nurse, they're a technician, they're a doctor, so they're kind of creating an anecdotal story. And I've heard, even through other comments, that this may not be as accurate if you had the real world data. And I know there's real data, that is the kind of like the holy grail of trying to understand the usability. And we actually have a product that we've added, or a functionality we added to our product, to be able to get that real world data to complement the traceability and see how the device is built with our product is being used. So we know that traceability is important. The accuracy of that traceability, especially when it comes to audits, is super important. So how can you get that more accurately, right? So that those audit burdens don't become fire drills and nerve-wracking type of situations.
Yeah, and so that leads us to the ideal solution, right?
Yeah.
So what kind of way of working with software would make this process a little bit easier? And as it says here, a workflow and tooling that makes regulatory documentation a natural byproduct of the development process, not a separate compliance burden. And so
Yeah.
basically that just means that the tooling itself is providing this trail for you. If you're using CMake, for instance, you can easily track the software version of which with the binary that I'm using. How was this built? What version of the source code? Um, Additionally, the it ties back into the quality assurance part, because when you're taking a hard requirement, you have to prove that you've satisfied it. And the automated testing tooling that we have that's exactly what it does. Is it proves that the hard requirement has been satisfied
Right.
by providing a verified set of test instructions. And so you can prove that yes, we actually did meet this requirement by putting this feature in. And by the way, we tested this feature properly, and here's the results
Right.
of every
Right.
test that we ever did.
Right.
And that's
Right.
automatically generated as you're developing. As the feature's being added, the test of that feature is automatically there. The record of that test happening is
So
automatically there for you.
working in parallel almost, right?
Yeah.
Yeah. Yeah. And then the result, time saved, weeks of time saved, which is significant to cost, and then obviously reduced audit risk, which is a pain for everybody. Okay, I think this is our last industry challenge, if I'm not mistaken. It is, because then we're going to show you a little bit of some show and tell next. But yeah, the last thing is these devices are multinational, right? And multilingual support for global deployment it is an essential. Is something that is needed. The challenge is that global product sales require multilingual UI options on the same device. So how does that work? And it's difficult because medical terminology must be precise for every language. So it must be accurate, and maintaining, let's say a chemical, a blood gas analyzer across 40 plus countries. It requires centralized translation management. And Sam, I know you're one of the ones that despite me working for a translation firm back in my medical translation firm back in my history, I understand how important this is and what a bear this is. But I know you had some really great thoughts on this. So I'll let you pontificate a little bit.
Yeah. Yeah. So it has to be easy both for, two stages, right? There's actually doing the translating and making sure that the translations are correct. And then there's getting them into the application, getting them
Yes.
to show properly. And so you have to consider things like left to right and right to left languages. Which one am I dealing with? You have to deal with locales. You have to deal with
well, and even text
units.
expansion. So
Yeah.
I always joke around with our German team that when you say something, and I minored in German in university, so that when there's a phrase in English it might be this big, then you translate to German, it's this
It's
big.
about three words
That on the
put
screen.
together.
Yeah.
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 Yep. Yep. You have to account for that, and that has to be part of your testing as well. You can't just test for one language, right? And so you have to make sure that you're working with something that makes it easy to do both parts, the translation and getting it into
Getting
the
into the
UI,
footprint. Yeah.
and being able to do that at runtime. You change languages at runtime. You don't want to provide a different binary for a different region. In
Right.
fact, you really don't want to do that.
Well,
So
Sam, does this also kind of go back into that first point of different archetypes of people that we say it has to be not information overload and stuff. I can imagine that information overload in one language may not be information overload in another language or something like that because of the way languages are kind of presented on the screen.
yeah, that's why it takes you can't just you need a real expert translator to do these things, because
Yes,
you can't just go to Google Translate
right.
and say, okay, now this is the German version or the Chinese version, because there's context, and the context is very important. One word might mean something different on one screen versus
That's
the other
exactly
screen. It
right.
depends on
Yeah,
where you are in the
yeah.
workflow. One word might mean a very different thing in a different stage of the workflow,
Yeah,
and
and I
that's why
remember
it
working.
takes that context.
Yeah, and I remember working for the translation firm that I worked for. That the responsibility is on the manufacturer. So if something is done improperly that caused an adverse event or misdiagnosis or something because the language wasn't there, that's not the fault of the user. That's the fault of the company that developed the actual technology. They're responsible for accurate translations.
Yeah. Yep.
Great.
And so the ideal solution is to have something integrated into the framework or the tool that you're using, that allows you to easily provide the translations to the application. So
Yeah.
in our world, that means providing a tool called Qt Linguist, which
Mhm.
allows people to use a UI to enter their translations for each of the phrases,
Mm.
and that will automatically produce a file. Behind the scenes, you don't even worry about what the production is, but it produces something that the application can consume at runtime to say, hey, if the user switched the language, here's a table. I know exactly what is
Right.
supposed to be displayed for this
Yeah.
language.
Yeah. So end result is one code base, 40 plus languages, reduced localization overhead, and faster global deployment. All right. So we're kind of got 15 minutes left. Let's run in. We want to show this kind of in action. So I'm going to switch gears here. We have a UI that we developed, a demo that we developed called OxyScan. It's a blood gas analyzer. Sam and I kind of created this together, and looking at these industry essentials, looking at these different challenges, we tried to kind of build a workflow and a demo for that. So we're going to quickly share that video with you. So I'm going to bring it up on the screen here. And Sam, if you want to talk through it a little bit and some of the decisions we made, here's the multi-language right here, right up the front.
Sure. Yep. So like we've been touting, right? It should be a simple interface, and this is what you're seeing. And it should be a guided workflow, and there should be
Mm.
no ambiguity. We shouldn't
Yeah, and the guided
allow.
workflow, not to cut you off, is down here with these different call outs here, start. And so as people are manipulating the screen, this guided workflow is right at the bottom, as you mentioned.
Yep. Yep. So it needs to be intuitive, right? Somebody who's never used this machine before shouldn't even have the option to do something incorrect. They should only have the option to move forward in the validated workflow, and that's kind of what this example application is showing you, right?
Yeah, and here I just want to just call out that we're looking at the multi-user archetypes here. What we did was within the screen, if you just had the demo, with just the digital part of the demo, you can choose the archetype. But we're actually trying to model this after real world, where we have a QR code to scan these different archetypes into. So in our demo that we've developed, there's a hardware kind of component there too to try to mimic real world situations. And so going through to very easy to read instructions to then the actual test being run. Um, and here all the way through to, the results being displayed on the screen and being able to navigate, right? Not being overwhelmed, giving some ranges where the normal is, different color combinations. We tried to color code, right? And then another view, which is more like a report that you could upload or print out or whatnot. So one that's more of a kind of a on-screen type of report versus a one that you can print out. And then coming to the end, obviously, simulating uploading to EMR, because this is where this point would take, and then kind of rounding things out at the end. with the final report being displayed and the option to start a new test. And what I like about this too is we've built in that we can expand this, right? We're only looking at simulating an arterial test. Could we also simulate a venous test or some kind of maintenance mode where you're changing the reagents? More to come, but we want to kind of make more of a workflow demo versus a ta-da, it looks great on the screen type of thing.
Yeah, Roger. One thing that you mentioned was the ability to incorporate hardware like a QR code scanner
Yes,
or a badge like NFC. You tap a badge and it knows who
yep,
you are. These are all really great things to have when you're working creating this type of product. And these are things that Qt provides out of the box.
right.
Near field communication libraries. Um, but another thing is we've seen now that we're getting information by touching the screen. The user's touching the screen to
Yes,
navigate. We're scanning QR codes. That's a different form of information coming into the device. But also one thing that we haven't even touched on here is data entry
hmm,
needs a keyboard. You
right.
need a virtual keyboard, and that's something that
Yeah.
Qt provides out of the box, right?
Mhm.
If you're needing to enter values, which the technicians are going to need to do that, having an out of the box solution for and fully customizable, by the way,
Yeah.
keyboard that just works is a huge speed up in terms of
Yeah.
development time.
Yeah, excellent. Okay, so I'm going to switch back to our. Thank you, Sam. This is great, and this is becoming very well received by our customers and the folks who've seen it. Let me go back to the PDF. Let's wind down here. We only have a few minutes left, and I do want to get to the Q&A. So just to wrap up some of the takeaways very quickly before we jump into Q&A, HMI design directly impacts patient outcomes. Poor interfaces create errors, burnout, costly downtime. From our side, Qt, our product, there are many solutions out there, but Qt does deliver safe, smart, seamless trifecta, deterministic performance, modular architecture, and cross-platform flexibility. And then regular compliance becomes a byproduct, right? Integrated tooling reduces validation cycles and audit risk. So just want to wrap up. We got about 10 minutes left. Please continue to put your questions in the question section. But Sam, I think we have about 5 minutes or so where we can cover some of those now. So
Okay.
I've got some in front of me. Let me go ahead and route it off. And I got a view on the time, so maybe we get to 2 or 3 of these. Okay, so first one. How important is the user interface when labs are evaluating new analyzers? Sam, you've worked for one of those companies. I'll let you comment on this one.
Yeah, just repeat it one more time for me.
Oh, sorry. How important is the user interface when labs are evaluating new analyzers?
Oh, yeah, very important. Very important. They don't want to spend a lot of time training people. Training is always costly.
I think we haven't touched training enough in this webinar, so thank you for touching on that. Yes.
Yeah, I think that. I mean, that's the main one, right? If it takes longer to train somebody, then you know inherently that the UI is too complex. The training time should be minimal, and a smaller training time means that the device is actually more intuitive, it's easier to
Mm,
use. Doesn't
mm,
take as much training, and that's
right.
what you're looking for. People want something that makes sense. They don't want to have to figure out how to do their own job. They should
And
make
guess what?
it's
No
a
one's
tool
pulling out a
at the end
user
of the day.
manual and reading it in front of the device either, right? I have never seen
Exactly.
that happen.
Nobody's gonna pull that. They don't even know the manual exists, right?
That's
It for them, it's a tool that helps them do their job, and the tool should be good.
right. Right. Well, look, I'm gonna stick on training, but this next question is kind of more about our product specifically versus just in general. So I just saw train. It says, how long does it take to train developers on Qt if they're coming from web development, right? Qt is more, embedded development, app dev development. Sam, you're the technical guy. I'll let you take this one too.
Yeah, web developers will actually have a pretty easy transition to using Qt, especially with QML. Being declarative, it's it can draw comparisons to some of the web frameworks, most popular ones that are out there. So and property bindings would probably be very similar to things that they do in the web world. They don't need to manually hook anything up, right? In QML, kind of the property bindings are doing all that great stuff for you. So web developers should have a pretty great time actually coming over to QML.
Excellent. Um, I'm going to take one. So I saw one that I think I can answer. So their question came in. They said they saw on the compliance slide where you're saying every button, workflow, error message needs to be documented, justified. We find this complex to be a complex task. Any best practices to streamline? And I think one of the things that you had mentioned was that in the traceability to have it in the tool chain. But I'll just repeat, we have a product that we're adding that we're just releasing with Qt to actually help in understanding how that product's being used, and we call it Qt Insights. So, this is where, for usability studies, the FDA, the EU, MDR, IVDR, and others call out the process by which this is done. And it's usually by observation and by interviews, right? You're asking the actual person using it how it's being used. Now, pre-market, that's more like a focus group. It's very a controlled situation. Post-market, it's how it's being used in everyday life, right? In those high pressure situations. So you can imagine the use in everyday life, maybe not using that equipment, 100% of the time all day. Maybe you're only using a little bit of the time, and maybe it's under a high pressure situation. So how accurate are those anecdotal stories? How accurate are those interviews, or maybe even the observations? Pre-market, even the controlled situations. I've been involved in situations where you ask somebody, well, why did you do that? Or I didn't do that. And you show them the video and they go, oh my God, because a lot of it's muscle memory. So, I think one of the things that we're very proud of is we're always looking at how we can facilitate better traceability, better actual data to talk about how the device is being used or what the functionality of the device is. And so we have if you're building stuff with Qt, a product with Qt, we have Qt Insights that can track that, and more to come. We also have a lot of regulatory support behind that as well. And funny I should say that, as I look up at the screen, it talks about what kind of support does Qt offer for medical customers, whether it be lab equipment, medical devices, or health IT. That's part of the support. So we're putting out parts of our product that will help facilitate better traceability with the data that you can pull from that device. But at the same time, we also provide support to our product that, yes, you could develop with Qt, but part of the 62304, part of that is, our product is a black box, right? You don't know how it was developed. You don't know how it was tested, how it was validated, what the cybersecurity testing was or whatnot. And so to have that, we provide that in a very supportive way, where we're not just dumping you into a document section. I'm actually working with you with my team to say, okay, do you need this test for this version of Qt? Here it is. And we're giving you only what is being asked of you. So we're not opening up a Pandora's box of more question, but be very, pardon the pun, surgical about what we provide to you so that you can use it and give it to the FDA. Because if the FDA asks you for, the validation for, a certain thing, you don't want to give them all the validation. I always use the thing in the United States when we are, buying houses and we have to get loans from the bank. The bank may ask us for 2 months of pay stubs. Don't give them 2 years, because that's just going to open up more questions. Same thing with these audits and such. We want to be very specific to the support we provide. So you're only answering the questions that are asked of you, or only get the information you need. But we do that over the life of our relationship with you and with our customers. So anyway, we are right at the top of the hour, Sam. Thank you so much. We have other questions that have come in. We will answer them as a byproduct of this webinar and shoot you those answers to those questions as we have them, as we come in at a later time. But we ran out of time today. But Sam, thanks so much. Your experience in this area really helped, I think, create a great conversation, a great webinar. So thank you very much.
Yeah, thanks for having me on, Roger, and thanks everybody in the audience for joining us today.
Excellent. And I encourage everybody to look at part 2 of this series. We're going to be talking about the healthcare IT subvertical and some of the challenges and values there. Until next time, thank you very much.
Thank you. Bye-bye.